Now in this question, they've given us 2 points, A and P. And they said that A and B are constant. Those are the coordinates of the point P. So we don't know the coordinates of the point P, whereas we know that A is minus 1, comma 1. They told us that the gradient of AP is 2. They want us to find an expression for B in terms of A. Now the first thing we want to do here is, since we know that the point P lies on the line segment AP, we want to first determine the equation of this line. So they've given us a point and a slope, so that's enough for us to determine the equation. So we can say that the line AP has the equation y is equal to mx plus c, and we know that the slope is positive 2, so y is equal to 2x plus c. Now since the point A lies on this line, when x is equal to minus 1, y is equal to 1. So 2 times minus 1 plus c. And what we end up with is 1 is equal to minus 2 plus c, and therefore c is equal to positive 3. And hence my linear equation is y is equal to 2x plus 3. So that's the value of c. Now, considering the fact that the point P has the coordinates a comma b, and it lies on this line y is equal to 2x plus 3. It lies on this line y is equal to 2x plus 3. So what that means is that when x is equal to a, y is equal to b. So now we have b is equal to 2a plus 3. And this is an expression for b in terms of a. So here we have b as the subject, and hence b is equal to 2a plus 3. All right, so for the next part, they want us to know, they've told us, so we know b is equal to 2a plus 3. That was the answer to the first part. In the next part, they've told us, they've given us a third point b, 10 comma minus 1, and they've told us that the distance AP between these 2 points is equal to AB. And now they're asking us we should calculate the coordinates of the possible positions of P. Now, let's try to visualize this first. What we have here is a point A whose coordinates we know is minus 1 comma 1, and a point P which has the coordinates a comma b. So the point P has the coordinates a comma b, and it can be in 2 possible locations. P could be over here or P could be over here. We don't know which side of A it lies on, but they want us to find the coordinates of P, given that AP, this distance from A to the point P, is the same as the distance from A to the point B, which is 10 comma minus 1. So this distance AB is equal to AP. So now we have to figure out the 2 possible values of A, and hence the 2 possible values of B for those given values of A. So considering the fact that AP is equal to AB, and we know the coordinates of A and B, we can first find the length or the distance AB, or the length of the line segment AB. So the distance between AB squared is equal to the distance between A and B, we know, is equal to x2 minus x1, the whole thing squared, plus y2 minus y1, the whole thing squared. Right? So the distance between AB squared is equal to x2. Let's take B as x2 comma y2, and A as x1 comma y1. So x2 minus x1 is going to be 10 minus minus 1. So we've got 10 minus minus 1, the whole thing squared, plus y2, which is again minus 1 for B, minus y1, which is 1 for A, the whole thing squared. So the distance AB squared is equal to 11 squared plus 4 squared. Hence the distance AB squared is equal to 125, and the distance AB is equal to the square root of 125. Now this distance is the same as the distance AP. This distance is the same as the distance AP. The distance between A and B is equal to square root of 125. And this is equal to the distance between A and P. So now how do we know the distance between A and P? Well, we know the distance between A and P, but we don't know the coordinates of the point P. So what we have to do is take the distance formula again, plug these values in, plug the values of the coordinates for A and P, and figure out the distance in terms of A and B. So let's do that. Okay, so the distance AP, again, is the square root of x2 minus x1, the whole thing squared, plus y2 minus y1, the whole thing squared. Y2 minus y1, the whole thing squared. Now over here we can take P, we can take the point P as x2 comma y2 and the point A as x1 comma y1 again. So the x coordinates, the distance AP, is equal to the square root of A, that's the point, that's the x coordinate of P, minus 1, the whole thing squared, plus y2, which is B, minus 1, the whole thing squared. And we know that this is equal to, square root of 125. So A plus 1, the whole thing squared, plus B minus 1, the whole thing squared, square root is equal to the square root of 125. Now, we have this, but what we don't know here, over here, is that what we have over here is A and B in an equation, and we have to figure out what the values of A and B are. Now, what we do know is that that B is equal to 2A plus 3. So what we can do is substitute this expression for B into this equation, and then we have an equation only in terms of A. So we have an equation only in terms of A. So let's do that. If we rewrite this equation right here, so we have this equation over here, and what we say is, okay, the square root of A plus 1, the whole thing squared, plus, for B we have 2A plus 3 minus 1, the whole thing squared, is equal to the square root of 125. And hence, the square root of A plus 1, the whole thing squared, plus 2A plus 2, the whole thing squared, is equal to the square root of 125. So if I expand these these brackets, what I end up with is the square root of A squared plus, or actually for the sake of simplicity, let's remove the square root on both sides first. So that makes it a lot easier for us. So now we have A plus 1, the whole thing squared, plus 2A plus 2, the whole thing squared, is equal to 125. So now we're going to get a quadratic expression. So let's expand this expression over here. We have A squared plus 2A plus 1 plus 4A squared plus 8A plus 4 is equal to 125. So now we have this expression. We have this expression over here. What we have to do now is solve for A. So we have 5A squared plus 10A plus 5 is equal to 125. So that comes out to 5A squared plus 10A minus 120 is equal to 0. So that's a quadratic expression here, and now we're going to solve for A. So what we end up with over here, is A squared plus 2A minus 24 is equal to 0. So what I've done is I've divided the entire equation by 5. Because all of these values are multiples of 5, I can just get a simplified form of this quadratic equation. And now we can use the middle term breakup, or you can plug these values into a calculator, and you end up with A squared plus 6A minus 4A minus 24 is equal to 0. Hence A times A plus 6 minus 4 times A plus 6 is equal to 0. And then we have A minus 4 times A plus 6 is equal to 0. Now what this expression tells me is that when A is equal to positive 4, or when A is equal to negative 6, then it has a value of 0. So what I end up with here is, that either A is equal to positive 4 or A is equal to negative 6. And now that we know that B is equal to 2A plus 3, what we also know then is that when I plug in either of these values of A, I should get two different values of B. So when A is equal to 4, B is equal to 2 times 4 plus 3. So that is equal to 2 times 4 plus 3, So that's 8 plus 3, which is 11. So we have the coordinate 4, 11 as one possible set of coordinates for P. And the other possible set of coordinates for P, is when A is equal to minus 6, B is equal to 2 times minus 6 plus 3. So that's minus 12 plus 3, which is minus 9. So the other possible coordinates of P, are equal to minus 6, minus 9. So those are our two possible sets of values for the coordinates of P. So P could be 4, 11, which is if it's on the right side of A, then it's going to be 4, 11. If it's on the left, then it's going to be -6, -9.